Hey everyone. All right, so for Unit 10, we're going to start off by looking at geometric sequences. So we actually covered what we called arithmetic sequences earlier on. So we're going to kind of build on that and do geometric sequences. So just to kind of start off, we're going to look at these sequences. So remember, a sequence is just kind of a string of numbers that are put together, and we're going to look for the pattern. So if I'm going from 5 to 8 to 11 to 14, you want to look for a consistent pattern that's happening between every single number. So you don't want to do like plus 3 times 3 plus 4 times 4, something like that. You want to have a consistent addition or consistent multiplication. So here, to go from 5 to 8, we're adding 3. So to go from 8 to 11, once again, we're adding 3. 11 to 14, we're adding 3. So we have a consistent pattern of adding 3. So our pattern here is just plus 3. All right, now looking over here, now we have 1, 3, 9, 27, 81. So let's see if I do this pattern. So to go from 1 to 3, I add 2. But to go from 3 to 9, that's adding 6. It's not the same change, therefore I can't really do addition here. Addition's not going to work. So I'm going to try a different change. So instead of adding, let's try multiplying. So to go from 1 to 3, we're going to multiply by 3. That's a 3. Multiply by 3. To go from 3 to 9, that's a 3. And to go from 9 to 27, once again, multiply by 3. And then 27 times 3 gives you 81. So our change here is actually going to be multiplication. All right, and then moving on over here. So now if you notice, our numbers are actually getting smaller. So I'm going to try subtraction. We're going to see if that's going to work. So to go from 200 to 100, that's minus 100. To go from 100 to 50, that's minus 50. It's not the same change, therefore it doesn't work. We have to look for a consistent change amongst all values. So instead of subtraction, now we're going to try division. So to go from 200 to 100, multiply by a half. To go from 100 to 50, once again, multiply by a half. 50 times 1/2 will also give you 25. So our change here is times 1/2. So keep in mind, you could also multiply times a fraction for your numbers to get smaller. So if you're ever wondering what the heck, what if the numbers aren't as clear? So what you can do to find that multiplier is you can do the second term over the first term to find that multiplier. So that would be 100 over 200, which gives you 1/2. So you can always do the second term over the first term so you can find that multiplier if you're having trouble figuring it out. Because I will say, a multiplier could be anything from like 1/2 to 5 to 6, or I could even throw a curveball at you and give you something like 3/2 or 2/3 or 5/7. I can make the multiplier anything I want to. All right, so just kind of a recap of arithmetic sequences that we did earlier. So we have the recursive form, the explicit form, the recursive form, and then we have the actual change. So with a arithmetic sequence, we have a of n equals a of 1 plus n minus 1 times d. So recall that a of n is the term value, a of 1. So let's actually do this. So this is the term value. So this is kind of the unofficial labeling. Then we have the first term, which is a of 1. Then we have the n value. So if it's like a5, so this is the indicated term. Which is right here. And last but not least, then we have the common difference. All right, that is weird. There we go. All right, so there's just the different components. So that's the explicit form. So remember, the explicit form lets you find any term, whereas the recursive form only lets you find the next term. So if you really want to be detailed, so the explicit form lets you find any term, whereas the recursive only lets you find the consecutive term. I can't spell. Everything's fine. All right, so with arithmetic, the change, which is our D value, is called a common difference. And that's if we are going to be adding or subtracting in the sequence. So up here, like for this first sequence that we did, for example, since we're adding 3, this would be an arithmetic sequence. Now, the next sequence we're talking about is called a geometric sequence. So it's the same idea. However, the explicit form is going to look a little bit different. So kind of the same idea, we have the term value, which is your A of n. And we're going to have the first term, which is your A of 1. And then instead of a common difference, we're going to have a common ratio. So we have a ratio, which is your R value, instead of a difference because we're multiplying. And then last but not, and then your N value here, this is going to be your indicated term. So confused why the bells are on. All right. So same idea, just different areas. All right, so now here is our recursive form, which is A of n minus 1 times R, which is your common ratio. So the common ratio is just because we're multiplying or dividing. And then this is your kind of like quick reference chart for arithmetic and geometric sequences, since you're now going to be using both. All right. But I will say, since we're looking at geometric sequences, this lesson is going to heavily emphasize geometric, but we're going to kind of touch back and review arithmetic as we go along as well. All right. So for each of these sequences that are provided, we want to write both the explicit and the recursive form of each sequence if it's possible. So when I say if possible, that may mean that the sequence has no pattern. My handwriting is so terrible. It's fine. All right. So for example, if we're doing a pattern for a sequence and it says like +2, +2, +2, +5, well, that's not a consistent change. So that would not even be a sequence that we're going to look at. Or if it's like ×2, ×2, ×2, ×3, once again, not a consistent change throughout. So that would not be a sequence that we're going to look at. All right. So looking here, first off, we have 5 to 15 to 45 to 135. So my instinct is to always start with multiplication since we're doing geometric. So to go from 5 to 15, that's ×3, ×3, ×3. So we have the same consistent change throughout. It's always ×3, which means because it's multiplication, that multiplication is going to imply that we have a geometric sequence. All right. Now we need the different components of a geometric sequence for the explicit form. So I have it written already right here. So we have the common ratio, which is our change, that is the R value. And then we also need the first term. So the first term is also provided to us, which is right here. So this is our A of 1. All right, so you really just have to kind of fill in the gaps. There's not much else to it. You only plug in the first term and the common ratio for your formula. So your sequence here, your formula, It's going to be the first term, which is 5, times your common ratio, which is 3. And then it's going to be raised to the n minus 1. So that's all you're plugging in. So there's your formula, at least for explicit. Now we also need to fill in and write the recursive. All right, so for the recursive, the only thing you're going to plug in is your common ratio. So we said the common ratio was 3. So a of n equals a of n minus 1 times 3. So this is going to be our recursive form. So that's all we're doing for these. So you just have to determine if it's going to be arithmetic or geometric, find the first term, identify the common ratio or difference, plug it into the formulas. All right, so looking over here. So now we're going from 1,000 to 500 to 250 to 125. The numbers are getting smaller, which means this is going to be a fraction. So if you remember, you can always do the second term over the first term to find the actual common ratio. So if you do 500 over 1,000, that's going to give you a common ratio of 1/2. So it actually works out for every single one of these. So we have a common ratio of 1/2. And over here, we're going to have a first term of 1,000. So this is your A1. So now we just got to write the formulas or write the equations. So I'm actually going to copy and paste the explicit and recursive stuff over here. There we go. I know it's geometric. If it was arithmetic, I'd have to rewrite the different formula. All right, so just got to fill in the gaps. So remember, you're only plugging in for your first term and your common ratio for the explicit form. And for recursive, you're only plugging in for the common ratio. That's it. We're just writing the formulas right now. We're not solving for a specific term yet. We will, but not yet. All right, so A of n equals your first term, which is 1,000. And then your common ratio, which is 1/2. That's all raised to the n minus 1. So this is your explicit form. All right, and then we got to write the recursive form. So we have A of n equals A of n minus 1 times 1/2. All right, so let's move on. Number 3. All right, so now we're looking at 12 to 17 to 22 to 27. So in this case, if I multiply, that would just be 17 over 12, which is a very gross number. So that's not going to work for all the values. However, if you add 5, that works for all of them. That's not add. There we go. All right, so in this case, because we're adding, that's going to imply that this is arithmetic. So we have to use the other side of the table. So we're going to be using the arithmetic explicit and the arithmetic recursive form. All right, so we still need to know the first term. So our first term here, which is 12. All right, so I'm going to go ahead and write out. Okay, so that's for geometric, so I don't want those. I'm gonna get rid of this. Oh, nope. All right, so what makes these different is the explicit is going to be A1 plus n minus 1 times the common difference. And then the recursive form, instead of multiplying, it's going to be plus the common difference. So just to kind of show you how they're similar, but also how they're different. Okay, so once again, we're just going to plug in. We're plugging in for A1 and the common difference for the explicit. And then for recursive, we're only plugging in for the common difference. So your equations down here. So we're going to have A of n equals the first term, which is 12, plus n minus 1 times your common difference, which is that change, which is 5. So this is your explicit form. And now for your recursive form, we have a of n equals a of n minus 1 plus 5. So just in case, I'm not sure if I said this earlier, your a of n minus 1 right here, I don't think I said this earlier actually. So for your recursive form, your a of n minus 1, this just means the previous term. All right. So if you're looking for A4, the fourth term, you're going to use A3. If you're looking for, say, A15, the 15th term, then you're going to use A14, the 14th term. You have to use the previous term in order to find the consecutive term or the next term. So just throwing that out there just in case, because I don't think I said that up here. So let's go ahead and put that up here just in case. So the previous term is a of n minus 1. And that applies to both arithmetic and geometric sequences, since they both have a of n minus 1. So I'm going to put this over here. Let's make it blue. Just change the color a little bit. Okay. So let's go on to number 4. So the next one here. So now if you notice here, we're going from 2 to -2 to +2 to -2 to +2, so on and so on. So we're constantly staying with the value of 2, but it's not actually changing. Well, not too much. So one thing I do know is we have a first term of +2. So the next thing I want to do is I want to see how the heck am I going to get a consecutive, or not consecutive, a consistent change throughout the entire sequence. So if I do 2 to -2, well, that is -4. But that doesn't give us a consecutive change here because, or consistent change here, because then the next one's +4. So we can't do addition or subtraction, which means we're going to have to use either multiplication or division. So to multiply, to go from 2 to -2, we multiply by a -1. So same thing here, times -1, and it actually works. So times -1 times -1. So -1 here is actually going to be our common ratio. So because we're multiplying, this is geometric. All right, so I have all the information I need. So I'm going to copy and paste all the geometric stuff from up here very carefully. All right, so now I just got to fill in the gaps. So for a of 1, or no, a of n equals your first term, which we said was +2, times the common ratio, which is -1, raised to the n minus 1. So this is our formula for this sequence, the explicit formula for the sequence. And now we want to find the recursive. So once again, just subbing in the r value. So we're going to have a of n equals a of n minus 1 times -1. We're just consistently multiplying by -1, just going in circles. All right, so that's all we're doing for that one. All right, now let's look at these next few. All right, so we're going from 14 to 9 to 4 to -1 to -6. So what I see here is we are subtracting 5. All right, so because we're subtracting 5, that is crooked. So because we are subtracting, that implies that we have an arithmetic sequence, which means we're going to have a common difference, not a common ratio. All right, so I'm going to go up here to number 3, and I'm going to steal all the formulas and stuff up here so I don't have to rewrite it. All right, so once again, we're just kind of plugging in the first term and the common difference. So over here, we know the first term is 14. It's always literally just the first number. All right, so now I'm going to go ahead and write in. So our first term is 14. So A of n equals 14 plus n minus 1 times your common difference, which is -5. All right, now notice how I wrote the common difference over here in parentheses because it's negative. If you just write -5, then that's turning into subtraction rather than multiplication. So you have to include parentheses if your common difference is negative. All right. All right, so same idea over here. So A of n equals the previous term, A of n minus 1, minus 5. That is your recursive form. Okie dokie. And then we have 10, 5 to 1. So to go from 10 to 5, that's -5. 5 to 2 is -3. 2 to 1 is -1. Subtraction is not consistent, can't do that. If I do division, that's multiplying by 1/2 for the first to second term, but it doesn't work for here. That would not be times 1/2. So because no operation works, that means there's no pattern. So confused. Why? So because there's no pattern, there's no sequence, there's no formulas that we can write, so it's just no pattern. That's terrible. We can do better than that. Wow, still terrible. It's fine. So whenever you come across a problem where it's not arithmetic or geometric, so what you're going to do on that problem is you're literally just going to draw a line through the problem and just cross it out. So whenever you cross it out, that's going to be your way of saying this is no pattern. You should definitely still write no pattern and then cross it out. Don't just cross it out. You still need to write no pattern so that we know you know it's no pattern. If you just cross it out, you're just omitting a problem. How dare you? Be in the corner. Be perfect. Close enough. Okay. So this is just writing the geometric, arithmetic, explicit, and recursive forms. So now I may actually tell you to find an indicated term based on what I give you. All right, so first off, I tell you the first term is 4, common ratio is 2, and you need to find the fifth term. So if I tell you the first term is 4, so I'm telling you this right here is a 1. And the common ratio, this is your R value. So because it tells you a ratio, this is so important, this part right here. It tells you ratio. That implies that it's going to be geometric. So if you ever have an R equals, or it tells you a ratio, geometric. That's going to tell you which sequence to use. All right, and then we want to find the fifth term, which is finding A5. Now here's the thing. It's kind of up here in gray on purpose. You can use the recursive or the explicit form. It doesn't matter which one you use. As long as you're finding that fifth term, that's all we care about. All right, so you use whichever one that you're more comfortable with. But I will say the explicit form will be quicker, but the recursive form will be easier. So it's really just dependent on what you want to do and how you want to do it. All right, so first off, I'm going to go ahead and just use the explicit form just because it's quicker. So I'm going to write out the geometric form, A1 times R to the n minus 1. So they told me the first term is 4. And we have a common ratio of 2. So 2 and minus 1. So there's our explicit formula. Now we want to find A of 5. All right, so I want to do A of 5 equals 4 times 2 raised to the 5 minus 1. So you can easily just plug this into a calculator or do it by hand. You do whichever one you want. I'm going to take the easy way. I'm going to do a calculator because I can, and that's the life I choose to live. So 4 parentheses 2 parentheses exponent, which is the caret key, then 5 minus 1. Enter, and that gives you 64. So you're going to have a of 5 equals to 64. See if I can get this working again. Absolutely not. Of course it's not. Okay, I think we're back. So a of 5 is going to equal 64. So this is what your final answer here will be. So the calculator will do the work for you. You just have to set up the equation. That's the only thing here. Okay. Or there's actually another way I just thought of in the calculator that I will show you. All right, so now I actually give it to you in terms of the sequence notation. So I tell you a of 1, which is the first term, is 100. R, which is 1/2, which R implies a ratio, which implies geometric. So you have to be careful in determining if it's going to be arithmetic or geometric. You have to look to see at the change. Is it a common difference or is it a common ratio? Now, instead of R, if I wrote, say, a D value here, for example, then that would be a common difference, which would be arithmetic. All right. So once again, I'm going to steal that same form. So a of n equals a of 1 times r raised to the n minus 1. And I'm looking for the third term here. Actually, let's do the recursive form this time. All right, so let's go ahead and do recursive. So a of n minus 1 times r. So if I want to find, I already know the first term is 100. So if I want to find the second term, I'm going to use the first term and multiply times 1/2. So that's 100 times 1/2, which is 50. So that's the second term. Now, if I want to find the third term, I'm going to use the previous term, which is the second term, multiply by 1/2. So that's 50 times 1/2, which is 25. So a of 3 is 25. The third term is 25. So like I said, you can do the explicit or the recursive form. It doesn't matter which one. I will say the recursive is going to take longer, but it is easier. Or the explicit, it's a little bit more challenging-ish, but it gets you the answer a lot quicker. Okay, number 3. All right, so once again, I see that R value, so we have a common ratio, which is going to be geometric. All right, so I'm going to go ahead and set up my equation. Now, here's the thing. I want to find the 8th term. So if I do a recursive form, I have to do it 7 times. So that's kind of a lot of writing. It's kind of a lot of time, which I don't know about y'all. I got things to do. So I'm not going to sit here and do the recursive form for 3 hours just to find the 8th term. Because I could be petty and tell you to find like the 50th term and tell you to find the recursive form, but I don't want to do that. So we're just going to use the explicit form because we can. All right, so a of n equals a of 1 times r to the n minus 1. So I want the 8th term. So I'm going to write out my formula first. So a of n, which is -2 times -5 to the n minus 1. And now I want to find the 8th term. So -2 parentheses -5, 8 minus 1. All right, and because I choose to take the easy route, I'm going to do this on a calculator. All right, so I'm actually going to show you a different way, or a couple different ways. So you can just straight up plug it in. So -2, parentheses, -5, then raised to the 8 minus 1. So 156,250. There's your answer. It's a huge number. But let's say I tell you to find the 8th term, then find the 12th term, then find the 15th term. If you don't want to plug it in 20,000 different times, what you can do is actually go to the table. So menu, table, let's get rid of this garbage. All right, so -2, parentheses, -5, parentheses, caret, and then x minus 1. No, there we go. And then you can go to the table. And then you can actually find each individual specific value. So first term is -2. Second term is 10. Third term is -50. Fourth term is 250. Fifth term is -1,250. Sixth term is 6,250. Seventh term is -31,250. Eighth term is 156,250. So on and so on. You can find any term if you just use the table, or you could just use run matrix. It's up to you. Whenever the numbers get extremely large like this, that's when you're going to have to actually go to run matrix and actually do them on there. So let's say I want to find -2, -5. Say I want to find the 10th term. So now the numbers are getting a lot bigger. So 3,906,250. So now instead of the 10th term, now let's say I want to find, say, the 15th term. So the numbers are getting extremely big. So I will never give you a value that is this large. I'm not that cruel. Okay. All right. Back to business. Oh my gosh. Okay, so your final answer over here, I lost track. 156,250. A of 8. 156,250. So you can write the commas, you don't have to. The answer choices will for sure have commas because it just makes it easier to read. Okay, so then there's going to be some application questions. So for this first one, so a chemist is studying the growth of a bacteria strain. The number of bacteria in the petri dish is currently 550, and it doubles every hour. So keep in mind, it starts with 550. So that means right here, this is going to be your first term. And because it doubles every hour, so that means doubles right here is going to be your keyword. So if it doubles every hour, that means your common ratio is going to be 2. All right, so does the sequence represent an arithmetic or geometric sequence? How do you know? So because it's doubling every hour, it's geometric. And you could literally just say that. So bacteria double they double every hour, which means multiply. So that multiply aspect is really what makes it geometric. All right. So we want to write the sequence in recursive form. So remember, this is a geometric sequence. So your recursive form is going to be a of n equals a of n minus 1 times r. So we're only inputting the common ratio here, which is 2, since it doubles. So we're going to have a of n equals a of n minus 1 times 2. So this is your formula for the recursive equation, and the recursive form. And now we want to write the explicit form. So the explicit geometric form. So here, we're going to have a of n equals a of 1 times r to the n minus 1. All right, and your first term, which is 550 bacteria, and it's going to double every hour. So this is your geometric explicit form. 550 times 2 raised to the n minus 1. And then we want to find after how, nope, I can't read. How many bacteria will there be after 4 hours? So this is a very fancy way of saying find a of 4. So find the fourth term. So if you already have that, nope. If you already have the explicit form or the recursive form, whichever one you want to use, you can literally just plug it in. So 550 times 2 raised to the 4 minus 1. So I'm just going to do this off to the side so I don't have to keep going back and forth. So 550 parentheses 2 raised to the 4 minus 1, which is going to give you 4,400. And because it is a word problem, you have to have your units. So there are 4,400 bacteria. If you just say 4,400, well, what does that mean? 4,400 what?